We're going to review the some coordinate geometry calculations. We're going to review midpoint, distance, and then partitioning a line segment. The midpoint is the middle of a line. So if I have my line segment here, I want to find the coordinate that's the middle. So we end up with a coordinate when we are done. The midpoint formula is basically the average of the x values and the average of the y values. So if I have a line here and my coordinates are -6, -5, and they can't read that very well, that's a -5, and 8, 2, the midpoint of line AB is going to be -6 plus 8 over 2, those are my x values, and -5 plus 2 over 2, those are my y values. -6 plus 8 is +2, over 2 is 1, -5 plus 2 is -3, so -1.5 when I'm done. If I look at this, 1 and -1.5 pretty much is right there, so you can see it visually if you use the graph. That's the midpoint. The distance formula is derived from the Pythagorean theorem because I can figure out the x distance between 2 points, and I can figure out the y distance between 2 points. To do that on a grid, you take the difference in the values. So the x distance is going to be 8 minus a -6. If I counted the squares, I would count 8 of them, and then I'd add another 6 to that. The y distance is going to be the 2 minus the -5. And once you have those two values, you would use the Pythagorean theorem to solve for the hypotenuse. The hypotenuse is the actual line segment, and that's the distance we want. So the formula for the distance, again, comes from Pythagorean theorem. It's the difference in the x values squared added to the difference in the y values squared, and then you take the square root. So in this case, the distance of AB is going to be 8 minus a -6 squared, and 2 minus a -5 squared. So we'll get some big O number in there. 9, 11, this is 14, let me see. So 8 and 6. If I square it, 14 squared is 196. And 7 squared is 49. So when I combine those, D is radical 245. When you are doing, sometimes it'll say reduce it to simplest radical form, but when you are doing things like coordinate geometry proofs, you can just leave your value like that because all you're doing is comparing the distances. So that's the distance formula. You'll use the distance and the midpoint when you do coordinate geometry proofs. Finally, we're going to talk about partitioning a line segment. We do this when the instructions say divide a line segment into a ratio. So let's say our ratio is 1 to 4. What you have to do first is find your scale factor. Your scale factor, and again, the order is important as well. If I want to divide line segment AB in 1 to 4, A is my starting point, and my scale factor is going to be the first value over the sum of the two. So it's really 1/5. I want to find a point that is 1/5 the distance from A to B. So I start at A, and I only want to go 1/5 the distance away. So here's how we do that. I have an x value, and I have a y value. So for the x's, my starting point is at A, so I start at -6, and to -6 I'm going to add 1/5 the full length. The full length is the distance, the difference between my ending value and my starting value. So that's going to be the difference between 8 minus a -6. So for my x value, it ends up being -6 plus 1/5 times 14. I don't know what that ends up being. That's 2.8 minus 6. So my x value, that is 1/5 the distance away, is negative 3.2. My y value is the same process. I start at negative 5, and to that I'm going to add 1/5 the full distance. So it's 2 minus a negative 5. So 1/5 of 7 is 1.4. Subtracting 5, and this is negative 3.6. So the coordinate that partitions that line segment in a ratio of 1 to 4 is negative 3.2 and negative 3.6. If I look at my graph, if I go over negative 3 in a little bit and then down, that point is roughly right there. So you can visualize it. It would take 5 of these segments to extend the full length of AB. So that's a quick review of midpoint and distance and partitioning a line segment.